Hello dear people, welcome back. The question is from GATE 2015 exam and is for 1 mark. We need to tell which of these statements is true. Have a look. TCP connections are full duplex. This one is true. See, if there is a client and there is a server, using TCP means we can send data in both sides. Okay, so this one can send data as well as receive data. So for this connection, client will be the sender. That means there will be a sender window. And for this connection, client will be the receiver. So there will also be a receiver window. So on any machine, we will have both windows, sender window and a receiver window. This one for sending data and this one for receiving data. Okay, similarly, for this connection, server is a receiver. So we have a receiver window and here we are going to have a sender window. Okay. Also, acknowledgements will be sent from both sides. If this one receives data, it will send acknowledgement. If this one receives some data, using this connection, it will also send the acknowledgement. Okay. So, first one is true. Now let us see second statement. It says TCP has no option for selective acknowledgement. This is false. In TCP, we have both kind of acknowledgements, selective as well as cumulative. Okay. See, if this is the sender side and this is the receiver side. Suppose sender has transmitted a packet to receiver. Now it is the decision of receiver that what kind of acknowledgement will be sent. Will it be a selective acknowledgement or will it be a cumulative acknowledgement? Suppose at this point of time, receiver has some data to send. Okay, see. Sender has also sent the data and receiver also wants to send the data. We have already seen it's a full duplex connection, so these things can happen. Now receiver will send this data packet, but what it will do, it will also add an acknowledgement in this packet only. Okay, so this is called piggybacking acknowledgements. Have a look. Now in this acknowledgement, there is also data, but this acknowledgement is for this data packet that is sent by the sender. It is called selective acknowledgement or individual acknowledgement because only one packet has been acknowledged in that acknowledgement. Okay. Now suppose at this time sender sends one more data packet, but receiver does not want to send any data. Okay. Now one thing that receiver can do, it can send a pure acknowledgement packet. That means there will be no data in that packet. It is just acknowledgement. Other thing that receiver can do is keep on waiting for more data. Suppose it receives more data in some time. So at this point of time, receiver can send a pure acknowledgement. Okay. Now this is a pure acknowledgement packet. That means there is no data. But interesting thing about this acknowledgement is that it will acknowledge all of these three packets at once. Okay, so this is called cumulative acknowledgements. Now, receiver could have decided to send individual or selective acknowledgements also. Okay, so that depends upon receiver, and it also depends that after how much time is the receiver getting data packets. Okay, it cannot just wait for like infinite amount of time and keep on accumulating that packets. Okay, so receiver has to send that acknowledgement after some time. But if in that time only it gets more data packets, it can just send one acknowledgement for all of them. Okay, so this one is false. Now let us see the statement number 3. It says TCP connections are message streams. No, this one is also false. TCP connections are actually byte streams. See, suppose there is a sender A and a receiver B. Okay. This is A and this is B. There will be an application layer at both A and B. Now suppose application layer decided to give 300 bytes of data to the transport layer. Message stream will just take this entire data at once and it will return this at once. Okay. See, transport layer will not divide these 300 bytes of data if we are talking about a message stream. So these 300 bytes will be given as it is to the lower layers after adding a header. Okay. At this side also, the lower layer will return 300 bytes as it is. Okay. So transport layer will just remove its header and it will verify that data is correct. Okay, there is no error. And then this will be returned in one go only to the application layer. That means if we are talking about a message stream protocol, that protocol will not try to divide a message. Okay. But TCP actually does not care from where a message starts and from where a message ends. In TCP, we have already studied about segmentation. So TCP can divide a message. Okay. Suppose TCP decided to create 1, 2, 3, 4, 5. TCP decided to create 5 segments. Okay. Now all those segments will be given to network layer and they will reach here. Network layer will give all those segments one by one. TCP will also return those segments to application layer one by one, but they will be in order. Okay. So what is happening? Application layer has given one message of 300 bytes. But at this side, because TCP is a byte stream, TCP is not a message stream. So on this side, that message will be received in parts. Okay, one part, then next part, then so on. Okay. And one more thing that can happen is, suppose that application layer has given two messages of 300 bytes. Because TCP is not message stream, TCP does not care from where a message ends and from where other message begins. TCP can also combine both of them in one segment and send it to the other side. Now application layer has given two messages, but TCP will return one big message of 600 bytes. Okay. So TCP does not care from where a message ends and from where a message starts. But if you talk about UDP, UDP is message oriented. UDP is a message stream. Okay. UDP will not segment a message given by application layer if possible. Okay. See, there is a limit of maximum length. If application layer gives larger message than that limit, then UDP will surely segment it. But if it is smaller, UDP will not segment. Okay. So UDP, it is message stream. TCP, it is a byte stream. Okay. So third one is also false. Now the answer to this question will be only statement number 1 is true. Okay.